Alright guys, welcome to the 10.1 exponential growth and decay functions notes. We're starting chapter 10. This will be the first bit of notes that we'll be doing for today, for this chapter. And we're starting with exponential growth and decay functions. Now, the whole idea, a question that is generally asked is, would you rather win $1 million or be given a penny day one, and each day for a month your penny doubles and then you cash in your winnings? All right, so that is a common exponential growth, exponential functions question, all right, because basically the way that this question illustrates is that a penny doubling every single day for about 30 days, and in the end will actually get you more than 1,000, because what you're doing basically is you're taking, 0.01, that's basically a penny in dollars, and you're basically multiplying by 2, but then you get 0.02, multiply that by 2, 0.04, and you just keep multiplying by 2. And what you're going to notice is these numbers are going to increase as they get larger. They're going to increase faster, okay? And that's what basically exponential growth is. It's something that you're multiplying by a specific number every single time. All right? That's what this chapter talks a lot about, is exponential functions and how to solve them and all that kind of thing. So now we have an exponential function as a function in the general form y is equal to a times b to the x. X is a real number, of course. A cannot be 0, so a can be any number but 0. B is going to be greater than 0, so b here cannot be a negative number, and it can't be 1. All right, so b has to be positive and not 1, basically. Okay, so we're going to look at graphing a few of these right here. So we have, the function y equal 2 to the x. Now, there is no limit to there is no restrictions on what we can plug in for x here. Can I plug in a 0? Yeah, because anything to the 0 power is 1. Can I plug in 1, positive numbers? Yes. Can I plug in negative numbers, fractions, decimals? Yes, you can do all that. Now, generally speaking, I'm actually going to get rid of this right here. Generally speaking, for all these graphs, I think these were the numbers you want to plug in. Because as you're going to see with these graphs, you don't want to go too high or too low. Because if you go too low, then you're not really going to get a whole lot out of it. It's going to be just really super low numbers. But if you go too high, you're going to get really large numbers, again, depending on the graph that you look at. So y to the 2, so what this is telling us here, and generally what I do is 0 in the positives first. 0 to the 0 power. Well, again, as I said, that's 1. This is 2 to the 1 power, which is 2. This is 2 to the 2nd power, which is 4. Now, negative exponents. I want people to be very careful on this. This is not the same as 2 times negative 1. This is going to be, this negative exponents are different. What I would do with that is plug that into a calculator. 2 to the negative 1 power. And if you do that, you should get out 0.5. If you give me a negative number right here, that is not right. These should not be negative numbers. Negative 2 right here. Again, take that negative 2 and plug it into your calculator. 0.25 is what you should be getting. All right. In fact, actually, speaking of which, I'm going to go ahead, pull up a calculator here. Right here. We'll go and pull that up. We'll go back to the notes here. All right. So we have this graph here. We're going to go ahead and graph it. So 0, 1 is right about there. 1, 2 is right about there. 2, 4 is right about here. And then negative 1/2 is right about there, and then the next one's just a little bit below that. So, and then the way that the graph's going to look is it's going to kind of flatline like this, because again, it's never going to go below this axis right here on the x-axis, because there is no number that you can plug in that will make this 0. All right, you can plug in like 2 to the negative 100 and 2 to the 1,000 or whatever, and it will still not be 0. Okay, so you will stop. Basically, you will flatline in this, and you will never go lower. Now for this one, y to the 1/4 times 2x. Again, we're just going to do this right here. Negative 2, negative 1, 0, 1, and 2, and I'm actually going to do this one by scratch here. Pretend like I don't have this one. So it's 1/4, 2 to the 0. Now again, remember order of operations. 2 to the 0, do the exponents first. So I'm going to do 2 to the 0 first. That's 1/4 times 1. 1/4 times 1 is 0.25. Next one is 1/4 times 2 to the 1. That's 1/4 times 2. If you multiply that out, that's 0.5. Erase some stuff here so I give myself some room. Next one, this one, that's 1/4 times 2 to the second. Do the exponents first. 2 to the second is 4. That's 1/4 times 4. Do that in a calculator, that's 1. Next thing is 1/4 times 2 to the negative 1. And again, this I'm actually going to show you in your calculator how you're going to do this. Now this is a graphing calculator. Come on. This is a graphing calculator. So again, you do your exponents first. 2, raise it to the negative 1 power. You get 0.5 and then times, and then 1/4, or I'm just going to do 1 divided by 4, is equal to 1.25. So we get 0.125 for this. Do the same thing, but with the negative 2. 2, raise that to the negative 2nd power. That is equal to this. Take that number and multiply it to the 1/4. And you get yourself 0.0625. And if you graph this one, 2, 1 is right here. So this one's just a little bit more shallow. You don't have to graph all of it, so it's a bit more shallower, like that one. But yet again, it's going to flatline right here. It's going to flatline right here. It will never go below 0. There's nothing I can plug in here to make this equal to 0. So, looking at our good old friends domain and range here. Domain, as I said, there is no limit to what I can plug into x here. I can plug any number I want in here. So if that's the case, our domain is going to be negative infinity to positive infinity. Because again, that tells me I can plug any number I want into x. Now the range, those are the numbers that I'm getting out. Once again, I will never get 0 out. That's the lowest that's my lowest possible bound. I will never have a negative number in here. So, 0, and then since I am going up, this is flatlining. This is not going down. This is not going to be pointing down, but since I'm pointing up, I'm already going to positive infinity, and that goes second. Don't put positive infinity right here. All right, don't put. Then, since we're flatlining at the x, again that's 0, we're going to put a 0 right there. So 0 to infinity. And again, since I will never actually touch that 0 value, we're going to have a parenthesis right there. All right. So our parentheses are going to be, so our things is going to be a parenthesis, 0, comma, infinity. And if I look at the range for this one, it's the same thing, all right? I'm approaching 0, but we'll never touch it. So I'm going to have a parenthesis 0 because I will actually never touch 0, comma, infinity. Okay? All right. Got another, graph a couple other ones here. All right, so got -2, -1, 0, 1, 2. -2, -1, 0, 1, 2. Do the 0 and the positives first. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. Do negative exponents. Do those in your calculator. 3, this button's your exponent button, to the -1. -1, excuse me. 3 to the -1. There we go. So about 0.3 repeating, so it's going to be about 0.3. And then -2. 3 raised -2. So about -1. Or about not -1, about 0.1. Let's grab this one here. Now, you're doing the same thing, but you are going to, come on now, multiply by -2. And actually, what you can do is you can just plug this straight into your calculator. So what I'm going to do here is I'm going to do negative 2 times 3 to the 0. So let's type this in here. Negative, come on, 2 times 3, raise that, 0. You get negative 2. Go back here. Negative 2 times 3, raise 1. You get negative 6. Put the positive 2 in there. Negative 2 times 3, raise 2. Get negative 18. Then do the negative ones here. Negative 2 times 3, raise to the negative 1. That's negative 0.66 repeating right there. So I'm just going to put negative 0.6. Just with a repeat bar right there. And then figure finally, negative 2 times 3, raise negative 2. About negative 0.2. Okay? So if we graph some of these here, 0, 1 is here. 1, 3 is right about there, and 2, 9 is here. Now again, this is also why I'm telling you, only use like the negative 2 to 2, because if I go any bigger, my number's off the graph. And if I go any smaller, then, well, as you're going to see, you're just going to get bigger, you're just going to get like 0.000 decimals, and that's not really going to help you. So negative 1, 3 is right there, then right about there. So we kind of have that graph right here. Domain, again, is negative infinity to infinity. And again, that's also this one as well. Because that tells you you can plug in any number you want for that x right there. All right? There's no number that you cannot plug in. Now, the range for this one, as we saw with the ones above, it's approaching the x-axis, but it will never touch it. So I have a parentheses 0, because that's the y value of the x-axis. It's approaching 0, but it will never touch. That's why there's the parentheses. Comma, infinity, because again, look at this, it's pointing up. We got this run right here. Now if we graph the second graph, 0, negative 2 is here, 1, negative 6 is here. I'm not going to do the negative 18 because that's just way down here, so don't worry about graphing that. 1, negative 0.6 is right about there, and then negative 2 is right about there. So this is now kind of a downwards facing graph. Not the best looking graph, but you know, doesn't have to be. Now this one's different. Instead of pointing up, we're pointing down. So instead of going down to positive and up to positive infinity, like this one's up here, you're going down to negative infinity. So we're going to write that first. But this one also approaches the x-axis and gets smaller and smaller and smaller, but it will never touch 0. So we put a 0 there with a parentheses. Again, we're getting really, really close to 0, but we will never touch 0 itself. Okay? Yep. Alrighty. So moving on, we're going to quickly go through these last here. Now we use an exponential function that with b less than 1 to model decay. And again, all of the ones that we did above start off low and then go up. A decay graph starts at the top and works its way down. So we can tell decay graphs by whether or not the number next to the x is less than 1. Now 0.12 is less than 1, so this is going to be a decay graph. 5 right here, that's bigger than 1. Bigger than 1, so that's growth. 6 over 5, again, this 3, this 0.2, this 100, that doesn't matter. I'm looking at the number right next to the x. 6 over 5 is bigger than 1, so that's going to be your a growth function. 1 over 2, again, I'm not looking at that 16 here. We're looking at this. 1 over 2 is about 0.5, less than 1. Less than 1. So that is going to give you a decay graph. And we'll kind of go over a little bit more of those in some of the next videos here. Thank you guys for watching. We'll see you later.